Every section of differential calculus involves determining the derivative of a function. The word, rate, is a comparison of two quantities with different units, and more often than not, involves time, for example, kilometers per hour, or meters per second. An important component of this section involves distance, speed, and time. The speed at which an object moves is defined as the rate at which an object covers a certain distance. In other words, speed equals distance over time. An object moves according to the formula, s of t equals 100t squared minus 200t plus 300, where s is the distance in meters, from a fixed point A after t seconds. Before we begin, note that it is common practice to denote distance, the letter s. The speed, also known as velocity, with which an object moves, is commonly denoted v. And time is denoted t. We are required to determine the object's distance from point A after 10 seconds. Determine an expression for the object's speed at any time t. Determine the object's speed after 10 seconds. Determine after how many seconds the object will reach a speed of 800 meters per second. And finally, determine after how many seconds the object will reach its minimum distance from point A, and determine what this minimum distance is. We are required to determine the object's distance from point A after 10 seconds. The distance from point A that the object is, at any time t seconds, is given by s of t equals 100t squared minus 200t plus 300. After 10 seconds, the object will be 8,300 meters from point A. Next, we are required to determine the object's speed at any time t. Looking at the diagram on the board, the speed of an object, v, is given by distance over time. The ratio, distance over time, is obtained by differentiating s of t. In other words, the derivative of s of t gives the velocity of the object. The velocity of the object at any time t is given by s-t equals 200t minus 200. The object's speed after 10 seconds is therefore 200 times 10 minus 200, which equals 1,800 meters per second. Next, we are required to determine after how many seconds the object will reach a speed of 800 meters per second. Thus, 800 equals 200t minus 200. Solving for t gives us t equals 5 seconds. So, after 5 seconds, the object will have acquired a speed of 800 meters per second. Finally, we are required to determine after how many seconds the object will reach its minimum distance from point A, and what this minimum distance is. Recall from the cubic function that at the stationary points of the function, the first derivative of the function equals 0. In other words, to determine the coordinates of the maximum and minimum local stationary points of the cubic function, we equate the derivative of the function to 0. Put a simpler way, whenever required to determine the maximum or minimum value of a function, differentiate the function and equate it to 0. Thus, to determine how long it takes the object to reach its minimum distance from point A, we differentiate s of t and equate it to 0. Thus, 200t minus 200 equals 0. Therefore, after 1 second, the object has reached its minimum distance from point A. To determine this minimum distance, substitute t equals 1 into s of t. The minimum distance from point A is 200 meters. Note that the function s of t is a quadratic function, so we can illustrate this minimum distance by sketching s of t. The object moves according to this quadratic function. The turning point, 200, is the point on the function where the object will be the closest to the fixed point A.